Lesson 1. Introduction to prime numbers. Prime numbers are natural numbers greater than 1 that have exactly 2 divisors. 1 in themselves. No simple method is known to generate prime numbers, being one of the hardest problems in mathematics. Current methods involve numerous verification calculations, or probabilistic methods. Characteristics of prime numbers. 1. Divisibility. A prime number cannot be divided without a remainder except by 1 and itself. 2. Exclusivity. Prime numbers are considered the building blocks of the natural numbers because any natural number greater than 1 can be factored into prime factors in a unique way, except for the order of the factors. This is called the fundamental theorem of arithmetic. 3. Infinity. There are an infinity of prime numbers. This fact was first demonstrated by the Greek mathematician Euclid. Examples of prime numbers: 2, 3, 5, 7, 11, 13, 17, 19. Remarks. 2 is the only even prime number, all other prime numbers are odd. Uses of prime numbers. Number theory. Prime numbers are central to many branches of mathematics, especially number theory. Cryptography. Algorithms based on the properties of prime numbers to secure data. A distribution of prime numbers. The study of the distribution of prime numbers leads to various interesting results and the development of new theories and theorems, such as the Riemann conjecture. Prime numbers play a fundamental role in mathematics and have practical applicability in areas such as information security and algorithms. About 30 years ago, after 20 years of searching, George Paraskan devised a mathematical table in which the natural numbers were arranged in several rows horizontally spaced 1 unit longer than the previous row of above. He began the study of prime numbers at the age of 14 and continued to delve into solving their position on the natural number series throughout his life. The first solution was a mathematical formula, but like all algebraic formulas, it gave negative results. This formula was published in Science and Technology magazine 1984. Although it gave an error after the number 120, it was an achievement, in that it gave the longest sequence of consecutive prime numbers resulting from a prime number verification formula. The table that constituted the achievement of the discovery of prime numbers was made by using statistical research methods applied to the study of plants in forestry research, where he worked as a laboratory technician in forest protection. These tables were a real chore for laboratory workers and technicians, who made tabular calculations, using figures they gathered from nature with efforts, sometimes extremely great and over the course of years. However, the natural numbers were perfectly adapted to tabular processing. After numerous attempts, he arrived at the table below, which allowed him to identify all the prime numbers without any calculations. He noticed that on the vertical of his table some numbers have their divisors, that is, all the numbers by which they are divided, and others have no divisor number except 1 in itself. Thus he managed to conceive the first non-calculating method of consecutive prime numbers, using a simple table. The table shows that the numbers 2, 3, 5, 7, 11, 13 are prime. If the table is continued to the right and down, all the prime numbers on the axis of natural numbers to infinity can be discovered consecutively. Lesson 2. Other methods of finding prime numbers. The table of finding prime numbers to infinity is based on a geometric structure made up of distances, line segments. This table replaces the numbers with the distances between the numbers on the strings. And in this case, the prime numbers are highlighted by the fact that they are determined only by 2 limits between the line segments, right of it, the first row, and the end of the first line segment found on the vertical of the place. This table has the merit of taking algebra out of the discussion of prime numbers, giving way to plane geometry. We can draw the conclusion that the sequence of prime numbers is therefore a plane geometry problem, which also has an effect on the sequence of natural numbers from 1 to plus infinity, so that a purely geometric knowable arrangement of points on strings of parallel line segments becomes an unknowable arrangement on the natural string of numbers from 1 to plus infinity. Since the problem of prime numbers is solved identically and simultaneously both algebraically and geometrically, it follows that the problem of positioning the prime numbers on the sequence of natural numbers can be considered solved. The same problem of positioning prime numbers is solved at the level of sea waves. If waves are created on the same system as the numbers on the strings in tab. Number 13, we will obviously be able to solve the problem without applying the equation called the Riemann zeta function. In fact, this approach is also perfectly valid in the case of the use of electromagnetic waves, the structure of atoms, spectra. The prime number problem is a bogus algebra problem. It's actually a geometry problem. In other words, we can describe a whole series of possible natural cyclical events, which have in them the matrix of geometry, which will give us the solution of the positioning of the prime numbers on the string of natural numbers. We can have a table of finding prime numbers, in which there is practically no number. This table has been referred to by the author as a template. The table above contains the left ends of the line segments that represent the numbers. This is the matrix for finding prime numbers and all divisors of natural integers. This is how an algebra problem became a geometry problem and turned into an inflexible mold. The fact that this mold becomes a fixed image, it turns into a law not only mathematical, but also natural, so that by replacing the numbers with electromagnetic waves, or waves of various sizes, reality becomes the expression of this mold. Whenever people notice strange events in the environment, they say that chaos reigns there. In reality, they have not yet come to know the mold of those behaviors, i.e. the law that governs them. In our case, we started from the strange sequence of prime numbers on the string of natural numbers. We discovered a table in which it is easy to see how they were born. We turned the table into a geometry problem, and then we came to identify the matrix. That is, the law that makes us understand why the prime numbers are so oddly placed on the string of natural integers. Children will make during the lesson the 3 types of tables, and try to understand the interconnection between algebra, abstract domain, which turns into geometry, natural domain, and arrives at the idea of mold, domain of universal laws in science. Lesson 3. Tabular variant number 2 of finding prime numbers. Is the table learned in the first lesson the only possible one? George Paraskan, another 30 years after the discovery of the first table, managed to discover new variants of it, which led him to make a series of new discoveries related to the relationships between algebra, geometry, and the matrix laws in the universe. The second version of the table for finding prime numbers. Here is a table that gives us through the horizontal game of numbers all the prime numbers identified to infinity on the vertical. Each horizontal row increases by the value of the number on the diagonal axis. In this table on its diagonal we can see the string of natural numbers. 1, 2, 3, 4, 5, 6, 7. The prime numbers appear between 2 identical numbers on the verticals on which we have no other numbers pasted, following this stringing horizontal series. The secret lies in the distances between the numbers on the horizontals of the table. Variation number 3 of the table of finding prime numbers is the easiest to do. The number 1 is written on the first vertical line from the left of the table in each square. Then the string of natural numbers of whole numbers is written diagonally. The table is completed with the same number from the head of the verticals at the distance indicated by the number itself. The result is fantastic. Horizontally we will find all the divisors for all the numbers in the string of natural integers. Prime numbers are easy to identify due to the fact that they have no divisors other than 1 in themselves. Children can be trained to continue this table and learn other prime numbers. By replacing the numbers with dots, they will find out the matrix of this table. The matrix is the law by which this table is constructed. The third variant of the table for finding prime numbers. The string of natural numbers is on the diagonal of the table, and the numbers on it are repeated vertically with the value of each as distances. Notice how the prime numbers stand out, having only 1 in itself as divisors. Extremely interesting was the idea of combining 2 tables from those previously exposed. This table is like a queen table with double confirmation of every prime number. The mixed variant of the table of finding prime numbers to infinity. In this table all prime numbers are confirmed twice, vertically up and horizontally left of the numbers on the diagonal, the string of natural numbers. Prime numbers are only divisible by 1 horizontally, and itself vertically.